All right, we're going to look at cubing and derived units for dimensional analysis. So, to get into the cubing stuff, there's a very important fact in chemistry. Hopefully, if I can do this live, I'll demo it, I'll show you, but 1 centimeter cubed is equal to 1 milliliter. Once you have a cubed unit is volume. Again, think of it, length times width times height. So if you do a centimeter times a centimeter times a centimeter, that's where they're getting the centimeter cubed from. So anything cubed, it could be meters cubed, inches cubed, it is a volume unit. But you need to know this fact here. It's essential to chemistry and density and things like that. So knowing that, let's do a couple examples. So here's how you do cubed problems. All right, so again, like dimensional analysis, we're going to start with what we know. So we know we have this. And we want to get it to meters cubed. So just like before, if centimeters is on top, centimeters has to go on the bottom. But the problem is right now, I can't cancel it out because it's not cubed. If it's cubed here, it needs to be cubed on the bottom, and it's not. But I'll come back to that in just a second. Can I convert centimeters into meters? Yes, because it's a base unit, no problem. So I'm first going to fill this in, and I'll show you how you do the cubing part. Which one's bigger, meter or centi? Meter is, right? So I put a 1 there. What's centi worth? It's worth 100. All right, now what you're going to do is you're going to cube the whole step. Now the reason I'm writing it like this is so that you cube the number, right? If a number is in parentheses and you put a cube behind it, you're going to cube the number. I have a lot of people who write 100 centimeter, put the 1 meter on top, and then they just want to do this. But then they forget to cube the 100 when they do their math at the end, and it screws them up. So I highly recommend you put the parentheses around it so you know to cube it. Now that it's cubed, these will cancel out. So in your calculator, you're going to cube 100, which is obviously going to be a very big number, and you're going to take 927 and divide by that. So you should get 9.27 times 10 to the negative 4th meters cubed. And that's all there is to that one. Sig figs are good. We're done. Okay? So I, again, highly recommend you do the parentheses. Now, let's try this one. Now, wait a minute. Milliliters isn't cubed. But if we use the fact on the other that I just showed you a second ago, we can go from meters cubed to centimeters cubed, right? And then go to milliliter. And it's actually super easy. So, again, start with what I know. Meters should go on the bottom. I know it's not cubed, but I'll get to that in a second. I'm going to turn it into centimeters cubed. So before I cube it, I have to look at this fact. 1 meter is 100 centimeters. Now I cube the step so that this cancels out. I am left with centimeters cubed on top, so centimeters cubed will go on the bottom. Can I turn that into a milliliter? The answer is yes. It's a 1-to-1, really easy. Still show that step because again, we're going to have harder ones where you're going to need to show that step and then go further with it. But this cancels out and we're done. That's all there is to that one. So again, the 100 is cubed, but now we're going to multiply because it's on the numerator times 36. So we get 3.6 times 10 to the, just double check, it looks like 10 to the 7th milliliters. And that's all there is to that one. All right. Now, let's talk about derived units. Derived units come from when you have a unit on the numerator, a unit on the denominator, and it came from plugging into an equation, like density is mass over volume. Acceleration is speed or velocity over time. Like you're plugging it in and you have a unit like grams per milliliter or grams per centimeter cubed or meters per second squared. Like you have a top unit and a bottom unit. Again, it came from plugging something into an equation. So this changes everything because now we have something on the denominator. So now my setup looks a little bit differently. If it's grams per milliliter, hopefully it makes sense to you that that milliliter should go in the denominator. It says slash, right? There's a division bar there. It should go in the denominator. Now, there's no number there. It's assumed that it's 1 milliliter. I don't care if you put the 1 in or not. If you need to, put it in. Now, you can see that we need decigrams on top. So we're going to go from grams to decigrams. But we're also going to change milliliters into liters. Do you think it matters which one we convert first? The answer is no. I usually, out of habit, convert the top one first. But it really doesn't matter because in the end, you're just multiplying and dividing and you're good. So, top unit. If grams is on top, grams needs to go on the bottom, right? Can I go from grams to decigrams? Yes, you can, because it's a base unit. Which is bigger? Grams. What's deci worth? 10. Cancel it out. I'm done. So I have decigrams on top, which is good. That's where I want it, right? But I'm not done with the bottom unit. Now, hopefully this makes sense. If milliliters is on the bottom and I want to cancel it out, it should go on the numerator, right? Opposites. That's the only way it's going to cancel out. So, can I put milliliters into liters? Yes, I can. Which is bigger? Liters. Mill is worth 1,000. This cancels out. So you can see I have liters on the bottom. Now I'm done because you can see I have decigrams per liter. So you just do 45 times 1,000 times 10. And you get 4.5 times 10 to the 5th decigrams per liter. And that's it. Okay? Keep things straight. Cross them out and when they're canceled. All right, to do this one, I'm going to have to give you the conversion factor. So 1 mile equals 1.61 kilometers. All right, so let's set it up. 673 miles over hours. Okay, again, it doesn't matter which one you do first. I'm going to put miles on the bottom, deal with that, get rid of it first, turn it into kilometers, because again, you can see we're going to go from miles to kilometers and hours to minutes. So I use my fact that there's 1 mile, 1.61 kilometers, cancel it out. So I have this on top, which is good, but now I need to get rid of the hours. So again, if hours is on the denominator, again, technically it's 1 hour. If you need to put the 1 there, go for it. So hour needs to go on top. It's the only way it's going to cancel out. And anyways, I want minutes on the bottom, right? So it works out. 1 hour is 60 minutes, and that's it. We're done. Let's calculate. So you would do 673 times 1.61 divided by 60, and we get 18.058 blah 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 blah. Again, too many sig figs. This has 3 sig figs, so we cut this down to 3, which means we're going to have to round that 0 up to an 18.1. And now we're done. All right, hopefully that one makes sense. Okay, one more to go, not in the notes. Let's see how this one goes. So again, I'm going to take my 8.343 hectograms over liters. Again, if you want to put the 1 there, put the 1 there. Now, hectograms into nanograms. Not an easy one to do in one step. I do not recommend it. Break it down in 2 steps. So I'm going to put hectogram on first, down on the bottom because it's on top, right? And I'm going to convert it into the base unit. Now, hectograms is bigger, right? So I put the 1 there. What is it worth? It's worth 100. So I cancel that out. Now, I don't want grams, so I'm going to put grams down there to cancel it out. I'm going to put nanograms on top. Which is bigger? Grams. What's nano worth? 1 times 10 to the 9th. Cancel it out. All right, so now I have nanograms on top, which is good. That's what I want. But I need to get rid of liters. So you can see this one's going to get a little bit long. Let me scoot it over some more. So, liters into meters cubed. Well, how are we going to do that? Ooh, well, we're going to have to go from liters to milliliters, right? Then go to centimeters cubed using that fact, and then go to meters cubed. So this is going to be a lot of steps, and that's okay. We can have some that are this long. All right, so again, liters is on the bottom, liters goes on top. I'm going to turn it into milliliters first. 1 liter, 1,000 milliliters, cancel it out. Milliliters is on the bottom, milliliters goes on top. I can turn it into centimeters cubed. It's an easy 1-1, but still put that step in so you can see what you're doing. But I don't want centimeters cubed, I want meters cubed. So finally, centimeters goes on top, meters goes on the bottom, but I want it cubed. Before I cube it, I put a 1, 100, right? Now I cube it. And now I can cancel that out. So now I finally have meters cubed on the bottom. So in your calculator, you can see we're going to cube the 100. That's what I would do first in my calculator. Times 1 to the 9th times 100 times 8.343. That's all my numbers on the numerator got multiplied. And then I'm going to divide by only 1,000. So you can see this is going to be a pretty big number. So I get 8.343 times 10 to the 14th nanograms per meter cubed. So let me know if that one doesn't make sense. That's one of the more harder ones. There will be practice like this in your packet. You need to do the practice in your packet so that you can handle whatever is being thrown at you. So please let me know if it doesn't make sense.